Hi, I'm Dr. Lakshmi Devi, Professor, Department of ECE, St. Peter's Engineering College. St. Peter's Engineering College is located at Kompally area near Dulapalli in Hyderabad. Myself in the Department of ECE, St. Peter's Engineering College. Now, in today's session, I would like to give introduction of digital image processing. As a first unit under JNTU affiliated colleges, first unit introduction of digital image processing. First, let us see what's the motivation behind digital image processing exactly enters into the technical field in ECE department as well as in CSE department. The motivation behind this particular digital image processing depends on two principal application areas. That is, improvement of pictorial information for human interpretation. Processing of image data for storage, transmission, and representation for autonomous machine perception purpose. For all these cases, it's very essential to have processing of an image which is not possible by the human eyes and which is not possible by the human brain. Because of that, the digital image processing enters into this technical field. Digital image processing, as comparing with the human perception, how you are going to differentiate with the human perception of vision and processing of image by the machine. With the human eye, whatever the objects we are observing, as a three-dimensional views we can observe very easily, like this perception. Here the diagram shows how you are perceiving any objects in front of us with the human eye. The same thing if you want to observe in the machine, that is digital images. In case of digital computers, it perceives as a two-dimensional view. That's the reason the basic definition of digital image processing depends on the perception of vision of machine only. This shows the difference between the human vision and machine vision of objects. So digital image processing, how we are going to define based on this particular perception of vision for the images which appears in front of us. Image is a two-dimensional function f of xy, where x and y are spatial coordinates and f at any pair of coordinates of xy is called the intensity or gray level of the image at that point. When xy and f are all finite discrete quantities, that image is called actually digital image. Analog image, how it is converted into the digital image. If you have any analog image while capturing, then you have to do the sampling and quantization. After sampling and quantization, the output of that particular image will call it as digital image. Nowadays, almost all capturing devices appears to be digital. That's the reason there is no question of analog images to be captured. So whatever the images we are capturing, then for machine processing purpose, we are doing the sampling and quantization. After that, the machine can process whatever the application and whatever the processing as an application point of view, we can process that particular images. That output processing image, we'll call it as an actually digital image, and the digital image output based on the process, we can have the features of that particular images. So what's an analog image? A two-dimensional function f of xy where x and y are spatial coordinates and f at any pair of coordinates xy is called intensity or gray level of image at that point is a digital. When above mathematical representation has continuous range of values representing position and intensity, that image is called analog image. These two are the basic differences between the analog image and digital image. A mathematical representation has continuous range of values representing the position and intensity. That image is called analog image. Now, image produced on the screen of a CRT monitor is an example of analog image. Now, let us see here. The analysis and manipulation of digitized image, especially in order to improve its quality, processing of digital images by means of digital computer will finally define it as digital image processing. Then, this figure shows the difference between the analog image and digital image. First figure of The first figure shows here the continuous changes of locations of values, locations of picture values. This is analog image and this one is the digital image. Here we have the discretized values. This is the basic difference between the analog image to the digital image. Obama figure. Now, what's a digital image? Contains The digital image contains a finite number of elements, each of which has particular location and value. These elements are called picture elements, image elements, or pixels or pels. In general notation, we'll call it as pixels. In two-dimensional image representation, the picture elements will call it as pixels. In the three-dimensional representation, as a videos will call that pixel as a voxel. In three-dimensional view point of view, we'll call it's a voxel. For the two-dimensional point of view, it's called a pixel. Advantages of this particular digital image processing compared to the human perception or analog image processing means fast processing taking place in the digital image processing, as well as it's a cost effective. Effective storage is a possible and efficient transmission because of a digital notation of images. It's efficient transmission, and scope for versatile image manipulation is also possible with the digital images. That's the reason these are advantages of digital image processing. Now, image processing is a method to convert an image into digital form and perform some operations on it in order to get an enhanced image or to extract some useful information from it. It is a type of signal dispensation in which input is image like video frame or photograph and output may be image or characteristics associated with that image. Based on application point of view, we can extract either output as image or otherwise attributes from that particular image. So usually image processing system includes treating images as two-dimensional signals while applying already set signal processing methods to them. It is among rapidly growing technology in today's life with its applications in various aspects of business. We are observing here and there so many applications of digital image processing. So because of humorous number of applications are there, because of increasing this particular number of applications, that's only the reason or the main reason enters that particular subject into the BTech course of digital image processing. Image processing forms core research area within engineering now, and computer science disciplines are also doing research over this particular digital image processing. Image processing basically includes the following three steps: importing the image with optical scanner or by digital photography. So analyzing and manipulating the image, which includes data compression and image enhancement and spotting patterns that are not to human eyes like satellite photographs. Output is the last stage in which results can be altered image or report that is based on image analysis. Whatever the type of processing we are doing on input images, finally, based on application, we can extract the information from the processing. Either it may be image, or it may be attributes, or it may be some characteristics, or it may be some features of images we can extract through this processing method. The main purpose of image processing, it depends on these five factors. It's divided into the five factors, means the first one is visualization, second one image sharpening and restoration, third one image retrieval, fourth one measurement of pattern, fifth one image recognition. Visualization observes the objects that are not visible. Image sharpening and restoration, to create a better image, will go for the sharpening and restoration. Image retrieval, seek for the image of interest. Then measurement of pattern, it measures various objects in an image with the different technologies appears in the total image processing. Image recognition, it's one of the important techniques in image processing, that is image recognition. Distinguish the objects in an image is actually called image recognition. Based on the distinguishing of objects appears in an image, we can will recognize that images, that is image recognition. These are the main processing areas or purpose of image processing, depends on these five main areas. Now, digital image processing techniques help in manipulation of digital images by using computers. As raw data from imaging sensors from satellite platform contains deficiencies. To get over such flaws and to get originality of information, it has to undergo various phases of processing. The three general phases that all types of data have to undergo while using digital technique are pre-processing, enhancement, and display information extraction. Mainly in this, it consists of some steps to follow in this particular processing. That is, importing the image via image acquisition tools, then analyzing and manipulating that particular images after acquisition, then output in which result can be altered image or a report which is based on analyzing that image. Finally, extracting of output after processing of any images, like analyzing and manipulating of the images output, it depends on application only. So, final again, after defining importance of this image processing and importance of the processing over analog images and advantages of digital images, let us see once again here the definition, then we'll go in depth of fundamentals of digital image processing. An image is defined as a two-dimensional function f of xy, where f1, x and y are spatial coordinates and the amplitude of f at any pair of coordinates xy is called the intensity of that image at that point. When xy and amplitude values of f are finite, we'll call that image as digital image. 4-bit color format is also there. So now let us see binary image. The binary image, as its name suggests, it contains only two pixel elements. Binary means 2. So 2 pixel element values it consists. The total image gets spread around total image with the 2 gray levels only, with the 2 pixel element values only, that is a 1 and 0, where 0 refers to black and 1 refers to white. This image is known as a monochrome or black binary image only. Black and white image. The image which consists of only black and white color is called black and white image, which is nothing but the binary image. If you want to distinguish this binary image with the monochrome images, binary image can consist of only two gray levels, that is black and white. But gray level image, it consists of ranging from black to white. So black to white, different gray levels are appears based on depth of the pixel. Suppose let us consider depth of the pixel 8 bits. 8 bits per pixel if it consists, how many gray levels there is a possibility to have in that particular image means 2 power 8 gray levels are possible. 2 power 8 is equals to 256 gray levels are possible. So range of gray levels presence in that image 0 to 255. Totally 256 gray levels are possible. So based on that, we have again monochrome image is also represented with the 8 bits per pixel in an image. The same thing 8 bits per pixel if you have represented for the color images, that will call it as 8-bit color format. So it is the most famous image format. It has 256 different shades of colors in it and commonly known as grayscale image. In this format, 0 stands for black and 255 stands for white and 127 stands for gray. In between we have different black and white shades. All the shades varying from black to the white, that all the shades will call it as gray levels. In between we have exactly 127 means it's also called gray level or gray value, but in between 0 and white we'll call all the values are gray levels. But in the color image representation point of view, it's having 0 as a black and 255 as a white, but still in between we have different color shades. That is for 8-bit color image or 8-bit color format we'll call it as. Then 16-bit color format. It is a color image format. It has 65,536 different colors in it. That is 2 power 16 2 power 16 different colors possibility, that is 65,536 different colors are possible in it. It is also known as high color format. High color format. In this format, the distribution of color is not as same as grayscale image. Definitely based on depth of the pixel or based on bits per pixel, there is a chance to observe the quality of an images. If it is 8-bit means totally 256 gray levels appears in that images. If it is 16-bit, 65,536 gray levels are appears. Gray levels in the sense color shades are appears. If still increases the number of bits per pixel, 24 bits per pixel instead of 16, the 24 bits per pixel images will call it as true colored images. The difference between the two true colored images as well as high color format images or true color images means whatever the color we are observing in the nature, the same color it appears in the photographs. Such images will call it as true colored images. At the time, the number of bits per pixel are 24 bits per pixel. Next. So how we are representing this particular image? We know images are represented in rows and columns. We have the following syntax in which images are represented. F of xy is equals to f of 0, 0, f of 0, 1, f of 0, 2 and so on, f of 0 n minus 1. Representation of this image with the number of rows and columns, m number of rows and n number of columns. So m by n is a matrix form notation for this images. M number of rows and n number of columns are there. In that case, it starts with the 0, 0 location of spatial location and ends with the m minus 1, n minus 1 locations. So m number of rows, n number of columns are there. So every element of this matrix is called image element, picture element or pixel. So phases of image processing. Acquisition. It could be as simple as being given an image which is in digital form. The main work involves in it, first one is the scaling, second one is the color conversion. The main phases of image processing if you observe, first one is acquisition. How you are capturing the image, what are the main tools it requires for capturing image that involves in this acquisition process. It's very simple process but which is in digital form. The main work involves one is scaling, second one is color conversion. If color conversion means red, green, blue, RGB scale will call it as RGB scale to grayscale or vice versa is possible for the processing purpose after scaling. Whatever the image we have scanned or whatever the image we have captured through our cam, but still there is a possibility to scale that images, then the color conversion is very essential. Depends on processing capability, we can do the color conversion. Then exactly what you are expecting, according to that you can do the operation over it. Then results you're supposed to expect. Then second one, image enhancement. It is among us the simplest and most appealing in areas of image processing. It is also used to extract some hidden details from an image and is subject to process. So now let us see here subject to process mentioned. Image enhancement is the second phase and third phase is image restoration. Image enhancement and restoration, both these processes are meant for improving the quality of an image. In both the cases, we can do the improving the quality of an image only, but enhancement will call it as a subjective quality assessment and restoration is called as objective quality assessment. So what's the difference between the subjective quality and objective quality? Subjective quality, without having any mathematical proof and mathematical derivation part, if you have analyzed or if you have defined the quality of an image based on involving the human for identifying the quality of an images based on the mean opinion score of the human beings, if you have extracted the quality of an image, that particular process in general will call it as a subjective enhancement or subjective analysis of evaluating the quality of an image. Coming to the third phase, restoration. It also deals with the appealing of an image, but it is objective process. Restoration is based on mathematical or probabilistic model or image degradations. Based on knowing the degradation model or degradation type, we can apply the reverse mechanism on retrieving the image as close as possible with the original images. That particular method will call it as image restoration. But in both the cases of image enhancement and image restoration, we are targeting on improving the quality of an image only. Next, color image processing. It deals with pseudo-color and full-colored image processing. Color models are applicable to digital image processing. Digital image processing, color models depends on the number of bits. It varies the quality of the color. Either it may be 8-bit, 16-bit or 24 bits. Now, even 32 bits of color processings are also available for high definition TVs. So, wavelets and multi-resolution processing. It's a foundation of representing images in various degrees. So multi-resolution processings as well as wavelet-based processings, especially we can use on specific applications for representing the images with the different degrees of perception. Then coming to the sixth phase, image compression. It involves developing some functions to perform this particular operation. It mainly deals with image size or resolution. Image compression, we know the importance of this image compressions nowadays. Without having the proper compression, it's not possible to even transmit the signal or upload the signal in any of live medias, live transmission purpose. So it's having its own importance of compression even on signals or images. Then coming to the morphological processing, it deals with the tools for extracting image components that are useful in the representation and description of shape. Wherever it is essential to extract some features of an images, that main concept will call it as the segmentation. Under the segmentation only we have these different morphological processings. Under this different morphological processing, the main aim of morphological processing for extracting of image components, that extracting of image components mainly useful for representing the size and shape or description of that particular objects appears in an image. Okay, so now overlapping fields with image processing. Let us see here. According to the block 1, if input is an image and will get out image as output, then it is termed as digital image processing. According to the block 2, if the input is an image and will get some kind of information or description as an output, computer vision. Then third block shows Input is some description or code, and we'll get image as an output, means that we termed as computer graphics. According to the fourth block, if input is description or some keywords or some code, and if we'll get description or some keywords as an output, then it is termed as artificial intelligence. I'll cover in the next video. Visual perceptions, foundation of mathematics and probabilistic formulations, human intuition and analysis play a central role. Choices made based on subjective visual judgments, physical limitations of human vision, how human and electronic imaging devices compare in terms of resolution and ability to adapt to changes in illumination. Perception of vision for the human vision is definitely different than perception of vision for the machine. So based on this basic difference between the perception of vision of the human to the perception of vision of the machine, we can categorize where the human fails for processing of images and where the machine success for processing of these images. Based on the distribution of the rods and cones, we can say this one is the blind spot. This one is the blind spot. The blind spot with our human means with the small experiment. Structure of the human eye, just we come across. Now here I have given some cross and dot. Just by closing your left eye and by closing your left eye with the left hand and move this particular structure, or placing on paper this cross and dot, move that paper closer to your eyes. While moving, just concentrate on cross only but not on dot. Just look into the cross. After moving closer that paper to your eyes until to some distance that dot is visible. After that the dot disappears automatically. But cross is visible. The dot disappears automatically. But still if you are moving the paper closer to your eyes, then the dot again appears. Just please, all of you, if you have any doubt on your eye structure, better to do this experiment. Mark this cross and dot on one white paper and keep at a distance 1 and 1.5 feet distance from your eyes, and close your left eye with the left hand and move that paper closer to your eyes. But look at only cross but not on dot. But even though we are looking at cross, while moving the paper closer to our eyes, the dot up to certain extent it appears. After coming near to the eyes, it disappears. But still if you are moving closer to your eyes, again the dot appears. During that particular period where it disappears, that we'll call it as actually the blind spot in our eyes. Please do that experiment, and that gives the personal experience to you whether we have the blind spot in our eye or not. So experiment to illustrate the eye's blind spot, just you can do as given here the description. Close your left eye and stare at the cross. Get your head closer to the image in a particular position. The dot should disappear. If you get even closer, the dot appears again. Here the number of rods distribution is very large as compared to the solid line distribution of cones, because cones distribution is only 6 to 7 million. Based on this, cones have bright light vision, even though number of cones 6 to 7 millions, but rods 75 to 150 millions are there. But still these are used. We have color vision for the human eyes. Perceived intensity is not a simple function of actual intensity. The visual system tends to undershoot or overshoot around the boundary of regions of different intensities. Based on the perception of vision, the intensity variations as well as actual intensity will vary from person to person based on the perception of vision, number of rods and cones present on human eye. This, if you observe this figure, this illustration of the match band effects perceived intensity is not a simple function of actual intensity. These are showing some abrupt changes from this particular gray level, this gray level like this. But actual intensity showing these are the abrupt changes. That's why it's a staircase showing intensity values from dull to the brightness. But perceived intensity, how we have means while observing here, it's having some change from this to here. These are the perceived intensities, but these are the actual intensities. Human perception, actual intensities for the machine perception. This simultaneous contrast phenomena, a region's perceived brightness, does not depend simply on its intensity. Based on the background, it varies. With this example, you can observe. So just here, black background and foreground appears to be a particular object, white. But here, this object appears to be the same color, but background it's become actually brighten as compared to this black. So if you are decreasing the black and increasing the white here, the background appears like this. But still, if you have placed this background still white, this appears to be white. If it is still white means, this particular object appears to be like this color. This is not exactly the color which we are going to perceive, but this figure is given in the textbook in such a way. But that shows based on the foreground, there is a chance to have, based on the background, there is a chance to have foreground light variations also. This shows, this totally depends on perceived brightness levels of the human eye. These are also some illusions, optical illusions for the human eyes. And this one, if you observe, these are four supporters, or you can observe this one is the square is there. And these are some lines, and here circle is there, some hollow circle. And here these two lines are appears to be the same length, but arrows here outside both the ends and here inside both the ends. Like this, here the staircase it appears, but these are not staircase, these are parallel lines. Like this, parallel lines and same length, and here perception of square, and here a circle in between of these lines. Like this, based on the perception, we are going to observe the different objects which are hidden in the given space. Okay, this light and the electromagnetic spectrum, this gives actually beyond the scope of this particular subject, but still it's very essential to remember visible spectrum details among the existing of electromagnetic spectrum. Nowadays, most of the subjects, it's very essential to know this electromagnetic spectrum, including electromagnetic waves and transmission lines, and microwave engineering, and still in VLSI to some extent, and then AWP, antenna wave propagation. Then here also in digital image processing, it's very essential to discuss about this electromagnetic spectrum. So electromagnetic spectrum varies from a minimum frequency level to the maximum frequency level. But this figure here, it shows 10 power 5 to 10 power 21 the frequency levels. So energy of one photon, and here frequency is the middle scale shows the frequency in hertz, and the bottom scale shows the wavelength. The relation between the frequency and wavelength, C is equals to F lambda. So based on that, C is equals to 3 into 10 power 8 meters per second. The wavelength, if we have evaluated based on the given frequencies, this is the wavelength scale. If the frequency increases here, wavelength is decreases, that we can observe. And this, at lower frequencies, we have the radio waves. With increasing of frequencies, first we have the microwaves, and then infrared region. Within this infrared, in between the infrared region to the ultraviolet rate, we have the visible spectrum. After ultraviolet rays, X-rays, gamma rays. X-rays, gamma rays and cosmic rays are there. At 10 power 24 around you can consider as cosmic rays. So this visible spectrum, if you observe, that is 0.7 into 10 power 6 and 0.4 into 10 power minus 6. That is, this actually the wavelengths here specified for visible spectrum, which varies from VIBGYOR colors, from VIBGYOR colors means from violet to the red. So red have maximum wavelength, that is 700 nanometers. Okay, this one is an actually visible spectrum. The electromagnetic spectrum, visible spectrum show zoom to facilitate explanation, but note that the visible spectrum is a rather narrower portion of the electromagnetic spectrum. For understanding of visible spectrum, here I have given a clear information 700 nanometers to 400 nanometers of color spectrum, which varying from red to the violet. That is a VIBGYOR colors. So with this VIBGYOR colors, how the frequency is varying, and frequencies varies from here 10 power 4 to 10 power 18. In between we have this particular visible spectrum. The varying of frequencies, how it is with the increasing of frequency, how it is decreasing decreasing the time period, that we can observe with this wave representation. So wavelength and frequency, how these two are related means lambda is equals to c by f, or otherwise c is equals to f lambda. Here f is nothing but v, representing as a v. So what's the relation between the Planck's constant and energy means E is equals to hv. Okay, that is a hf, f or hv. So c is equals to velocity of light in free space, and lambda is microwave, wavelength in microns. That is, here we are representing in nanometers 700, or otherwise zero point 0.7 micrometers. So micrometers or nanometers, that is the notation here given. This digital image fundamentals already just we come across, but as an overview just I'll give here. Light void of colors, that is a monochromatic color or monochromatic light, we'll call it as, but only attribute in what way we can represent here means either intensity or gray level. So range of measured values, we'll call it as actually the grayscale of images or grayscale of the pixels. Then monochromatic images, grayscale images. Monochromatic images are also called grayscale images. Chromatic light source, frequency plus radiance, luminance, brightness. These are all some more frequently used words in this particular chromatic light sources, frequency, radiance, luminance, brightness, like. So radiance is a total amount of energy that flows from the light source is called actually the radiance. And what is luminance means measure of the amount of energy an observer perceives from that particular radiance, we'll call it as luminance. From that particular light source or from the light radiance, we'll call it as luminance. So just know the difference between the radiance and luminance in this. Radiance means total amount of energy that flows from the light source is a radiance. Luminance means measure of amount of energy an observer perceives from a light source is luminance. Brightness, there is no, subjective descriptor of light perception, practically impossible to measure. That's the reason there is no proper definition appears for the brightness. So advantages of digital image processing. Humans are limited to the visual band of electromagnetic spectrum, but imaging machines cover almost the entire electromagnetic spectrum ranging from gamma to the radio waves. Thus, operate on images generated by sources that humans are not capable to sense. These include ultrasound, electron microscopy, and computer generated images. In this low level process, first involves primitive operations such as image pre-processing to reduce noise, contrast, enhancement, and image sharpening purpose. Thus, a low-level process is characterized by the fact that both its input and output are particular information. I'm closing this session. In the next session of fundamentals of image processing, we'll continue the remaining topics in the next video. I hope I have given a clear information on understanding of digital image processing with this particular input. Thank you very much. Thank you. So based on this, we have